Look at your hand right now. Whatever shade it is, that color didn't come from nowhere. Every single one of your ancestors, no matter where you're from today, had the exact same skin color. Not most of them, all of them. Around 300,000 years ago, when Homo sapiens first showed up in Africa, the whole species had dark skin. There were no pale populations anywhere on the planet yet. That means every civilization, every culture, every face you've ever seen in a history book traces back to one dark-skinned founding population. So at some point, something changed enough to reshape entire continents worth of people. What was it? To answer that, you need to understand what skin is actually doing. It's not just packaging. It's your body's largest organ, and one of its main jobs is blocking UV radiation from the sun. UV light damages DNA. Enough damage in the wrong place becomes cancer. The pigment that colors skin, melanin, is a built-in sunscreen. More melanin, more UV blocked, less DNA damage. In equatorial Africa, under some of the strongest UV exposure on Earth, dark skin wasn't a preference, it was survival. But there's a second reason it mattered just as much, and it's one almost nobody talks about. UV radiation also destroys a molecule in your bloodstream called folate, a form of vitamin B9. Folate is essential for early pregnancy, specifically for the neural tube, the structure that becomes the brain and spinal cord. Too little folate in the first few weeks of pregnancy, sometimes before a woman even knows she's pregnant, and the neural tube can fail to close properly. In a sun-soaked environment with no clothing and no shelter, lighter skin meant more UV reaching the bloodstream, more folate destroyed, more pregnancy complications. So in Africa, dark skin was doing two jobs at once, protecting DNA from cancer and protecting folate for the next generation. Two separate threats, one shield. So dark skin was, by every measure, working, which raises the real question, why did it change at all? Starting somewhere between 70,000 and 100,000 years ago, groups of humans began drifting out of Africa. Not one migration, just generation after generation moving a little further north. And as they moved, the sun itself effectively got weaker. At higher latitudes, sunlight hits at a lower angle, passes through more atmosphere, and UV drops off fast. That same UV blocking melanin that had been essential in Africa suddenly became a liability because there wasn't a new problem to protect against up north. There was a new problem to not block. That problem is vitamin D. Skin makes vitamin D using UVB light. It's essentially a solar panel, and vitamin D isn't optional. It controls calcium absorption, which controls bone strength. Without enough of it, children develop rickets, bones that bow and deform. In pregnant women, the same deficiency can soften pelvic bones badly enough to make childbirth dangerous. Put dark, UV-blocking skin in a low-sunlight northern environment with no supplements and no fortified food, and that same shield starts working against you. Over thousands of years, individuals with slightly less melanin absorbed slightly more vitamin D, had slightly stronger bones, and slightly better odds of surviving childbirth. Generation after generation, the average skin tone in northern populations drifted lighter, not by choice, just by which bodies kept more people alive. Here's the part that actually surprised scientists. For a long time, the assumption was that this lightening happened slowly, over hundreds of thousands of years, as people spread north. Ancient DNA says otherwise. A well-studied specimen known as Cheddar Man, who lived in what's now Britain about 10,000 years ago, still had dark to medium skin and blue eyes. Even after tens of thousands of years living at northern latitudes, European populations hadn't dramatically lightened yet. The very fair skin now associated with northwestern Europe appears to have spread widely only in roughly the last 6,000 to 8,000 years. In a species that's existed for 300,000 years, that's under 3% of the whole timeline. So what changed? The Neolithic Revolution, the shift from hunting and gathering to farming. Hunter-gatherer diets included fatty fish, organ meats, and other foods naturally rich in vitamin D. Farming diets were mostly grain. That dietary vitamin D source largely disappeared right as people became almost entirely dependent on their own skin to make it. On top of that, farming populations were bigger and more densely connected than scattered hunter-gatherer bands, so a helpful mutation could spread through thousands of people in a fraction of the time. Diet loss plus population density hit fast forward on a process that had been crawling along for tens of thousands of years. It's worth sitting with this for a second. Skin color, the thing that's been used to sort and divide people for most of recorded history, is at its core a UV calibration setting, your body's inherited best guess at how much sun protection your ancestors actually needed based on where they lived and what they ate. Even something as seemingly fixed as blue eyes traces back to a single shared mutation near the Black Sea only about 6,000 to 10,000 years ago. Every blue-eyed person alive descends from that one change. It's younger than farming itself. Dark skin isn't the primitive version, and light skin isn't the advanced one. Dark skin is the original, ancestral setting our whole species started with. Light skin is the more recent adaptation built for a specific environment. The same sun that made dark skin essential in one part of the world made it a liability in another. It didn't pick sides. It just radiated indifferently, and evolution did the sorting. If you want more real history, the stuff hiding in your own biology, the rest is on the channel. Stay curious.